Welcome back to the deep dive. Today we are strapping in to look at something truly massive. Infrastructure projects, so huge, so expensive, they literally shape economies.
We're talking about the mega projects in oil and gas and petrochemicals.
Exactly. Think sprawling refineries, those huge LNG terminals, even offshore platforms that are basically cities floating on the ocean.
Yeah, and these aren't just big building projects, are they? They're incredibly complex. You've got thousands of specialized parts, global supply chains, technical standards where failure just isn't an option. Get it wrong, you're looking at years of delays, billions lost. It's intense.
So, okay, if the stakes are that high, how does the industry manage it? All that complexity, and maybe more importantly, all that risk.
Well, that's where this core framework comes in. It's really
Yeah.
the backbone of how these things get done.
Yeah.
The EPC model.
Right, EPC. And our mission today is to really unpack that. We want to get into how EPC gives you that single point of accountability everyone talks about.
And how owners manage to transfer such enormous risk. Plus, we need to nail the difference between EPC and its cousin, EPCM. That one caused a lot of confusion.
Okay, so by the end of this deep dive, you, the listener, should have a really solid grasp on how these global mega projects actually get built.
Let's start with the basics then. EPC, what's it stand for?
Engineering, procurement, and construction. Simple enough, but the key is it's a delivery method where one contractor, just one entity, takes full responsibility.
Full responsibility for everything. Designing it, buying all the stuff, physically building it, the whole package.
Which is why you hear the term turnkey so much, right? The idea is the owner just comes along at the end and, well, turns the key.
Exactly. Ready to operate.
Okay, so let's break down those three letters, E, P, and C. To really get the power of this model, we need to understand what each part involves in these massive projects.
Let's start with E for engineering.
And like you said, we're not talking about back-of-the-napkin sketches here.
Oh, definitely not. This is the brain work. It starts with process simulations, figuring out how the plant will actually work, what the chemistry and physics demand. Then it goes all the way down to incredibly detailed drawings like piping and instrumentation diagrams, P&IDs. They're like the roadmap for every single pipe and valve.
The plant's circulatory system, almost.
You could put it that way, yeah.
Yeah.
And this phase also includes building complex 3D models. Those are vital later on to make sure pipes don't clash with steel beams, for instance.
Okay, makes sense. Then comes P, procurement. This sounds like more than just ordering parts.
Oh, it's a beast. Procurement is basically a huge parallel project running alongside engineering.
Right.
You're sourcing highly specialized equipment from all over the world. Think vendor selection, quality checks, incredibly complex logistics, dealing with customs, currency fluctuations,
Wow.
often over several years. Honestly, how well procurement runs can make or break the entire project timeline, especially because it overlaps so much with the design work.
Got it. And finally, C, construction, the actual building part.
Yep, boots on the ground, putting it all together, starts with pouring massive concrete foundations that's often on the critical path, meaning any delay there delays everything.
Okay.
Then erecting the steel structures, lifting and setting enormous pieces of equipment, think huge cranes, and finally installing miles and miles of piping. That piping work, it actually takes up the most man-hours on site, surprisingly.
Interesting. So you put E, P, and C together under one contractor. Why is that structure so dominant in oil and gas?
It really comes down to that single-point responsibility. For the owner, it massively simplifies things. They deal with one company for absolutely everything.
So if there's a design flaw or a piece of equipment is late or there's a construction issue.
There's only one door to knock on. One entity is clearly accountable for fixing it and for the overall success or failure. No finger-pointing between designers and builders.
Okay, but wait. If one contractor is taking on all that commercial responsibility for potentially billions of dollars, why would they sign up for these LSTK lump sum turnkey deals? That sounds like an insane amount of risk.
It is a lot of risk. But, well, first, they're specialists in managing exactly this kind of risk. And second, they charge a significant premium for taking it on.
Ah, okay.
The LSTK contract gives the owner maximum cost certainty. The price is fixed up front. So risks like cost overruns or schedule delays, they mostly land on the contractor's shoulders.
And the owner has protections.
Absolutely. Contracts always include things like performance guarantees. These make sure the finished plant actually performs as promised. Maybe it's meeting a certain production output or energy efficiency target.
Right. And you mentioned LSTK, but sometimes you see other acronyms like EPIC or EPCC.
Yeah, you do run into that alphabet soup. EPC adds installation and commissioning. EPCC is engineering, procurement, construction, and commissioning.
But fundamentally,
Fundamentally, they all point to the same core idea: a fixed price, a guaranteed outcome, and that single point of responsibility. It's all about the turnkey concept.
okay, let's walk through the actual timeline. It all starts way before the EPC contract, right? With the owner seeing a need. Project initiation.
Exactly. The owner first has to justify the whole thing.
Yeah.
That means doing rigorous feasibility studies. Can we technically build this? Do the economics stack up? What about environmental permits? Social license?
A lot to consider, even before you think about hiring someone.
A huge amount. Only once the project gets the green light, the funding is approved, then you move into the main engineering stages.
And the first big one is FEED, front-end engineering design. You called it a bridge.
Yeah, it's the critical link between the initial concept and the detailed blueprints. It's not super long, maybe 6 months, maybe 12.
Okay.
And cost-wise, it's relatively small, perhaps 1 to 3% of the total project budget.
But sounds like it's crucial spending.
Oh, it's probably the most valuable money spent on the entire project. A good feed package gives you enough detail, like preliminary process flow diagrams, PFDs, to get a decent cost estimate, usually what they call a Class 3 estimate.
Accuracy.
Plus or minus, say, 20%. Good enough for the owner to make that final investment decision, the FID.
Gotcha. So after FEED, you commit the big bucks.
Right. Then you launch into detailed engineering. This is the marathon phase. It can take 18 to 30 months, easily.
And costs a lot more.
Significantly more. Maybe 8 to 12% of the total project cost goes just into detailed design. This is where all the final P&IDs, the 3D models, the structural plans, everything gets finalized.
Okay, and you mentioned procurement running in parallel here for a long time, like 18 to 36 months. Why so early?
Because of long lead equipment.
Yeah.
These are massive, custom-built items you just can't buy off the shelf.
Like what?
Think huge distillation columns for refineries, specialized chemical reactors, massive gas compressors for LNG plants. These things can take, I don't know, 12, maybe even 24 months just to manufacture after you order them.
Wow, 2 years lead time.
Exactly. I remember reading about one project where a giant reactor vessel was so big it needed a special ocean barge and took months just to ship it across continents to the site.
So you have to order those super early.
Absolutely. If you delay ordering one of those critical long lead items, the entire multi-billion-dollar project schedule can just unravel.
Okay, so the equipment starts arriving after, what, a year or two? And that's when the physical construction phase really ramps up, lasting maybe 2 to 4 years.
That's typical for a mega project, yeah.
Eh.
Site execution is, well, it's organized chaos, dominated by pouring concrete for foundations, erecting steel, and then installing all that equipment and piping.
With thousands of tasks over several years, how on earth do they keep that schedule under control?
The main tool is specialized software, usually Primavera P6. It's the industry standard for this level of complexity. It goes way beyond a simple Gantt chart.
How's it work?
Well, first they build what's called a work breakdown structure, or WBS. It's basically a hierarchical list that breaks the entire project down into smaller, manageable chunks of work.
Okay.
Then, crucially, they define the logical relationships between all those tasks. And it's not just task A must finish before task B can start.
Complex than that.
Much more. You use logic like start to start. Maybe painting starts 5 days after steel erection begins, or finish to finish with time lags. It lets you model how activities realistically overlap.
Right, because things happen in parallel.
Exactly. And once all that logic is built in, the software can run a critical path method, CPM analysis.
Ah, the critical path. I've heard of that.
It's the absolute core of project control. The CPM identifies the specific chain of tasks where any delay, even just 1 day on one task, will push back the entire project completion date.
So that's where management focuses all their attention.
Every single day, they live and breathe the critical path, managing resources and solving problems there first, because that's what protects the finish date.
Okay, so managing that critical path is paramount. And for the owner, locking in the finish date and the cost is key. Which brings us back to the contract type, that lump sum turnkey LSTK model.
Yeah, LSTK is really the gold standard if you're an owner prioritizing certainty. The price is fixed up front. You know what you're paying for the final working plant.
And that transfer of risk for costs and schedule delays we talked about?
Is maximized under LSTK. It primarily sits with the EPC contractor. That's the deal.
But is there middle ground? What if the owner wants to incentivize the contractor to be, even more efficient, maybe save some money?
There are variations. You sometimes see a turnkey with target pricing model.
How does that work?
Well, you agree on a target price for the project. If the EPC contractor delivers below that target cost, both the owner and the contractor share the savings. That's the gain share.
Okay.
But if the costs go above the target, they both share that extra cost too, the pain share,
Yeah.
usually up to a pre-agreed limit.
So it gives the contractor skin in the game to control costs while still keeping that basic turnkey structure.
Exactly. It aligns incentives a bit more.
Now, talking about pain, the contractor is taking on huge financial exposure, even with a premium, so they must have ways to limit their downside, right?
Oh, absolutely. Standard practice is to include liability caps in the contract, meaning the contractor's total financial responsibility for things going wrong is capped at a certain amount. Often, it's capped at 100% of the total contract price.
So they can't lose more than the project is worth.
Generally, yes. And there are often subcaps within that. For instance, their liability just for schedule delays might be capped at, say, 20% of the contract value. It limits their exposure.
And beyond those caps, insurance becomes critical.
Hugely important. Both sides rely on comprehensive insurance policies.
What kind of policies are we talking about? What does the owner really need to see in place?
Well, there's the basic stuff like contractors' all-risk CAR insurance. That covers physical damage to the construction site itself, fires, floods, that sort of thing.
Okay.
And professional indemnity insurance, which covers errors in the engineering design. But from the owner's perspective, arguably the most vital one is delay in startup, DSU insurance.
Delay and startup.
Sometimes it's called advanced loss of profits, ALOP. This is crucial because if the project completion is delayed past the agreed date,
The owner isn't making money from the plant.
exactly, they're losing potentially massive amounts of expected revenue. DSU insurance covers those financial losses caused by the delay. It's a critical safety net for the owner's business case.
Okay, we've spent a lot of time on EPC, buying that certainty, transferring risk. But you mentioned there's a major alternative, EPCM. Sounds almost the same.
Sounds similar, but the difference is night and day. Really fundamental.
So EPCM, engineering, procurement, and construction management, that M is the key.
That M changes everything. EPCM is a services-only contract. Think of it like hiring a consultant or a project manager, not a builder who guarantees the final product.
Okay, so if the EPC contractor delivers the finished asset and takes the commercial risk, what does the EPCM contractor do?
They act more like an advisor or an agent for the owner. They provide the engineering expertise, they manage the procurement process, they oversee the construction work, handle cost control, scheduling.
But they don't build it themselves or buy the equipment in their name.
No. And this is the absolute crucial difference. Under an EPCM model, the owner directly holds all the contracts with the construction subcontractors and the equipment suppliers.
Ah, okay. So the owner signs the checks for the concrete supplier, the piping contractor, the turbine manufacturer.
Exactly. The EPCM firm manages those contractors on behalf of the owner. But the contractual relationship, and therefore the ultimate commercial risk, stays with the owner.
So that's the big trade-off. With EPCM, the owner keeps much more direct control over decisions, who gets hired, what equipment is bought.
But they also keep significantly more commercial risk. If a supplier fails or a contractor underperforms, it's the owner's problem to solve directly, financially, and legally.
Whereas with EPC, that risk would sit with the main contractor.
Precisely.
So why would an owner choose EPCM then, if EPC offers that nice, clean risk transfer?
Well, you typically see EPCM being used when the owner themselves has very strong, sophisticated in-house project management and engineering teams.
They feel capable of managing the risk themselves.
Yes, and they want that higher level of direct involvement and control over all the key decisions throughout the project. By taking on the risk, they avoid paying the large risk premium that's baked into an EPC price.
So it can potentially be cheaper, but with more risk and requiring more internal capability.
That's the calculation they make.
You know, this contrast really underscores the sheer scale of risk that those big EPC companies manage when you think about the giants in this space.
Right. Firms like Technip Energies, who are world leaders in LNG, or Saipem, huge in offshore work, or Bechtel Corporation, who do massive projects everywhere.
These companies aren't just technically brilliant. They are built financially and structurally to absorb and manage these multi-billion-dollar risks concentrated on them.
It's their core business model. Hashtag tag outro.
Okay, let's try and wrap this up for you, the listener. The essence of the EPC model, its core value, is really about that single point of accountability.
Maximum risk transfer from the owner to the contractor.
And getting that guaranteed performance and cost certainty. The whole turnkey idea, one contract, one price, one working plant at the end.
But there's always a trade-off, isn't there? The main one for the owner is typically cost. You pay a premium for shedding all that risk.
A significant premium, usually.
Yeah. And the other downside is flexibility. Once you sign that LSTK contract, making changes to the design or scope becomes very difficult and very expensive. You can get bogged down in variation claims.
So sticking with the plan is crucial. Now, ultimately, even with LSTK, that EPC contract puts immense commercial pressure, billions of dollars of exposure, onto one single company.
It really does concentrate the risk.
And while we talked about liability caps offering some protection, history shows that catastrophic project failures can happen. Sometimes the financial fallout can seriously strain even the biggest contractors, potentially exceeding those caps in practical terms.
That's true. A major failure can have devastating consequences.
So maybe here's the final thought to leave you with. Given how critical these huge LSTK projects are for energy supply, for economic development, how should owners and investors really assess the deep financial health, the genuine financial stability, and the demonstrated risk tolerance of their chosen EPC partner?
You're saying look beyond just their technical resumes.
Exactly. Before you entrust them with a project that could define your company's next decade, how do you get comfortable with their ability to withstand the inevitable storms that come with managing such concentrated risk? That financial due diligence seems just as critical as the technical review.
That's a very important point. Definitely something to chew on.
Indeed. Food for thought. And that is all the time we have for this deep dive. Thanks for joining us.
Thanks, everyone.
We'll catch you next time.